All right, this will be the key for this homework here, finding the zeros of a quadratic. Now, on this homework is not only questions about finding the zero, but lots of other questions about quadratics. We start with problems where we need to solve equations by taking square roots. This happens when there is no b value. If you see an equation with no b value, you can solve it using this technique. It's very simple. We just simply need to isolate our variable and then take a square root. So here we go. Number 2, I'm going to subtract 3 from both sides. I get 4. X squared equals 36. I'm going to divide both sides by 4. Then I get x squared equals 9. Now that I've isolated my x squared term, take a square root of both sides. Then we get x equals positive and negative 3. Whenever we take a square root, we get a positive and a negative answer. Let's try that again with, let's see, number 4 looks a little bit more difficult, so let's try that. I'm going to subtract 4 from both sides. I'll get 8x squared equals 648. Divide both sides by 8. And get x squared equals, grab my calculator, (648) divided by 8, 81. Square root, x equals positive and negative 9. All right, we should be good on those types of problems. Don't make your life more difficult by trying to factor something like that. If you don't have a b term, you don't need to. All right, in these problems, we do have to solve by factoring. I'll start with number 5 here. Let me add 4 to both sides. The reason I'm doing this is I want to get one of the sides equal to 0. Because once I get one of the sides equal to 0, I can use something called the zero product property. But before I can do that, I've got to factor this. Let's see, this can be a v. The v equals 0. I set up this structure. Now I need two numbers that multiply to be 4, but add to be negative 5. Let's see, that's going to be negative 4 and negative 1. Those multiply to be positive 4, but add to be negative 5. Now, I set them each individually equal to 0. This is that zero product property, which states that when I'm multiplying things, if one of those things is 0, then the whole thing will be 0. And since I've got a 0 over here, that'll make the equation true. So v minus 4 equals 0. V minus 1 equals 0. Add 4. V equals 4. Circle that. Add 1. V equals 1. Circle that. The next one I want to do is problem 8. Problem 8 is kind of a little bit more tricky because now I don't have a c value. Or I can say that the c value is 0. It actually makes the factoring go a little bit easier. You'll see here in a second. Let me start by getting a 0 on one side by subtracting 8n from both sides. I'll get n squared minus 8n equals 0. Now, both of these terms have an n, so I can pull an n out. This is called taking my greatest common factor out. And now it's been factored. So I pulled an n out of both of these, and you can check that this works. If I distribute that n back, I should recover this original expression. All right, this is set up to use zero product property. Set each of these linear factors equal to 0. This one just gives us an answer right there, n equals 0. N minus 8 equals 0. We add 8 to both sides. We get n equals 8. Those are our two answers. You can check them by plugging them in. We get either 0 equals 0 or 64 equals 64. They both work. Just because it's here, let's do number 7. Add 4v to both sides. We get v squared plus 4v equals 0. Factor in a v. and I'll get that v equals 0 and v equals -4. All right, when you don't have a coefficient, it's always the opposite of the second value here. This can be thought of as v plus 0. Moving on. All right, let's do number 10. For this, factor to find the zeros. So when I say find the zeros, another way to think about that is the x-intercepts. Convert to vertex form to find the vertex, then sketch a graph of each function. So for number 10 here, I need to factor that. So I've got y equals x squared plus 6x plus 8. This is simple factoring because my a value is 1. So I can just jump straight to this structure here. I need two numbers that multiply to be 8 but add to be 6. Those numbers are 4 and 2. All right, let's set this equal to 0 now. So 0 equals x plus 4 and x plus 2. This is going to give me the value x equals -4. This is going to give me the value of x equals -2. So we just found two ordered pairs. -4 comma 0 and -2 comma 0. If I plug in -4, I get 0. If I plug in -2, I get 0. So they're xy pairs. That just gave me two x-intercepts. Right there and right there. So let's go ahead and plot those. -4 comma 0. Go there. -2 comma 0 is going to go there. Let's convert this to vertex form now. So what I'm going to do is I'm going to now create this structure, keep the plus 8. I'm going to fill it in. I always fill this the same way, with half of the b value here, and then subtract away that value squared. So it goes 1/2 of that, subtract away its squared. Divide by 2, square it, and then subtract it away. All right, one more step to simplify this. Y equals x plus 3 squared minus 1. My vertex is at -3 comma -1. Vertex, h comma k. So now that I know that the vertex is at -3 comma -1, I can fill that in. And now with those 3 points, I could sketch the rest of my parabola. Let me add in one more point. If I plug in -1, I should get a 3. If I plug in -5, I should get a 3 as well. Connect this up. We've got a sketch of this parabola. All right. Moving on. Let's do number 12, I guess. Number 12, let me factor that. That's going to become simple factoring. I need two numbers that multiply to be -3 but add to be -2. Those numbers are going to be -3, 1. So that gives me the x-intercepts of +3 and -1, because those are the values that will make these linear factors 0 and therefore make the whole thing 0. Those are my x-intercepts, 3 and -1. Let's find the vertex now by converting to vertex form. I create this structure now. Keep the -3. This value here is always half the b value. Then I subtract away that squared. I get y equals x minus 1 squared minus 4. I go to 1 comma -4 as my vertex. And I can fill in the rest of the parabola from there. And we're done with that problem. All right, so the rest of these all require factoring by grouping, or at least I think they all require that. We'll see if maybe we run across some, one that doesn't, but we'll just try and do about half of these, and hopefully that'll help you out. So number 13. First thing I'm going to do is I want to get it into standard form equals 0. So we want to set it equal to 0. So we want it to equal 0. So I can do that by adding 3a squared to both sides. I'm going to get 14a squared plus 33a plus 18 equals 0. Now, because I cannot simplify this any further, at least I don't think I can. It doesn't look like any of these are divisible by the same number. So what I'm going to do is factor in by grouping. The first step is to split that 33a into two separate terms that add up to be 33a. And we can use variables to represent that. We'll do that for this first problem, d and e. So we want d plus e to equal 33, but d times e does not equal 18. It equals 18 times 14, which equals 18 times 14, 252. All right, so now I'm looking for factors of 252 that add up to 33. Well, we've got two factors right there, 18 and 14, but those add up to 32, not 33. So they're close. We know the factors are going to be close. So one thing I could do is I could just start dividing 252 by numbers that are close to 18 and 14. I'm just going to do that now. Let's try 252 divided by 16. Nope, that gives me a decimal. 252 divided by 12. That gives me 21. And that works out really well. So 252 divided by, or is equal to 12 times 21. But 12 plus 21 is equal to 33, which is what we wanted. So this is our winner. And I got it just by using my calculator, dividing numbers that I thought might be factors of 252 until I found the one. All right, so back to our equation. We've got 14a squared. I'm going to split that 33a into a 12a and a 21a. Let me think if I want to rearrange that. I think I do. I'm pretty sure we always want the bigger number to be on the right here to make factoring by grouping work. So we'll just try this, and if it doesn't work, then we'll know that it's not that way. But it's looking like when we split it, we should always put the bigger one on the left. All right, create my two groups, and then factor out the greatest common factor of each. The greatest common factor in this one is a 7a, leaving behind a 2a plus 3. And the greatest factor in this here is a 6, leaving behind a 2a plus 3 again. So it did work. So we got that same factor twice, so we're going to write this like as if we're undoing the distribution that's happened here by getting these two terms together and then copying down a copy of this term here. This is correctly factored, plus it's equal to 0, so now we can use the zero product property. 7a plus 6 equals 0, minus 6 minus 6. We got 7a equals negative 6, divide by 7, divide by 7. A equals negative 6/7. Then we'll set this linear factor equal to 0. 2a plus 3 equals 0, minus 3 minus 3. 2a equals negative 3, divide by 2, divide by 2, a equals negative 3 halves. All right. So there are the two values that make this equation true. Double check it by plugging them into the original equation and making sure it balances. All right, let's do another one of these. Let's do 15. 15 looks a little more complex. I'm going to start by getting all of my terms onto the left-hand side. I'll subtract 3v from both sides. Now I've got 9v squared plus 10v equals negative 8 plus 6v squared. Subtract 6v squared from both sides. Get 3v squared plus 10v equals negative 8. Add 8, add 8. 3v squared plus 10v plus 8. All right, I'm looking to split that 10 into two values. Those values need, we'll call them D and E. They should multiply to equal 3 times 8. They should add to equal 10. 3 times 8 is 24. So I'm looking for factors of 24 that add up to be 10. Those are going to be, it's not 12 and 2. It is 6 and 4. So 24 is 6 and 4. And those also add up to be 10. So let's do that now. I'm going to split this. Bad color. 3v squared plus 6v plus 4v plus 8. Split it into my two groups. And we get 3v times v plus 2 plus 4 times v plus 2. This now becomes, I'll write it over here, 3v plus 4 times v plus 2 equals 0. Set each of these individually equal to 0. 3v plus 4 equals 0. Subtract 4 from both sides. 3v equals negative 4. Divide by 3, divide by 3. V equals negative 4/3. And over here, we got v plus 2 equals 0. Subtract 2, subtract 2. V equals negative 2. All right, let's do, looking at these, they look about the same. We'll do 17. So let me add 8n to both sides. And also subtract 3 from both sides. Here we now have 10n squared plus n minus 3 equals 0. I can't factor out that 10, so I need two numbers, d plus e equals 1. D times e equals negative 3 times 10, or negative 30. So factors of negative 30 that add up to be positive 1. What are they? Factors of negative 30. It's not 15 and 2. It's not 3 and 10. It is 6 and 5. So negative 30. And I want to get a positive 1. So let's do positive 6, negative 5. That's how I want to split up that n. So now I've got 10n squared plus 6n minus 5n minus 3 equals 0. Factor out the greatest common factor, which is 2n. Then we have a 5n plus 3 and a negative 1 to get a 5n plus 3 equals 0. Split that into its two factors now, 2n minus 1 and 5n plus 3 equals 0. Now set each of these individually equal to 0. We get 2n minus 1 equals 0. Add 1, add 1. 2n equals 1, divide by 2, n equals 1/2. And over here, 5n plus 3 equals 0, minus 3 minus 3, 5n equals -3, divide by 5. We get n equals -3/5. Let's just see how we did there. (1/2) and -3/5. Yep, got it right. All right, so that's all the problems I'll do. And good luck with the rest of them.